Hey everybody, welcome back. I hope everybody's doing well. Welcome to my channel. I am Math. Today we're going to be talking about a very interesting topic called the chain rule. It's one of the most powerful differentiation methods for finding derivatives because it allows us to find the derivative of more complex functions. We discussed the power rule, the product rule, and the quotient rule. So the chain rule will allow us to do more. In order for us to understand the chain rule, though, we have to kind of start with understanding composite functions. What is a composite function? Suppose I have two functions, f and g. The definition of a composite function is f of g of x. That is, f is a function of g of x. Let's look at an example. Suppose I had a function f of x is equal to the square root of x. And I had another function, g of x, which is x squared plus 1. What does f of g of x mean? It essentially means wherever I see an x in my original function f of x, replace that x with the function g of x. So if f of x is the square root of x, then f of g of x is going to be the square root of. Now we replace all x's by x squared plus 1. So that's going to be x squared plus 1. So we replaced our x here by g of x, which is x squared plus 1. Suppose now I was asked to find f of g of 3. What is that? Well, g of 3 is going to be 3 squared plus 1, which is 10. Therefore, f of g of 3 is going to be the square root of 10, because we just take g of 3 and substitute that in wherever we see x. Let us look at another example. Suppose I had f of x equals 4x plus 8. And g of x equals 1/4 x minus 2. And I was asked, what is f of g of x? Well, again, remember, wherever I see an x in f, replace that with g of x. So I'm going to have 4, replace all x's with g of x, so 1/4 x minus 2 plus 8. That's going to be 4 times 1/4 x, that's just x, and then 4 minus 2, that's minus 8, and then we have a plus 8. So we're left with x. So that's a little introduction on composite functions. Now we're ready to move on to the chain rule. Suppose y is a function of u, and u is a function of x. So y equals f of u, and u equals g of x. Then we can find dy by du, which is just f primed of u. And we can find du by dx, which is g primed of x. Now the chain rule allows us to find the derivative dy by dx. And it tells us that dy by dx is going to be dy by du multiplied by du by dx. Please don't treat this as a cross multiplication. That is, you can cancel out this du by du. You cannot do that. It's dy by du multiplied by du by dx. Let us look at some examples to drill the topic in. Example 1. Let u equal 3x minus 6 and y equals 7u plus 10. And we're asked to find what is dy by dx. And we said, well, dy by dx is going to be dy by du multiplied by du by dx, which is d du of 7u plus 10 multiplied by d dx of 3x minus 6. Proceeding, the derivative of 7u plus 10 is just 7 multiplied by, and the derivative of 3x minus 6 is just 3. So our answer is 21. That is to say that dy by dx is 21. Let us look at another example. Suppose I had y equals f of x, which is equal to 1 all over x cubed plus 1 to the 5th. And I was asked to find dy by dx. We can simplify finding the derivative of this function by doing a substitution and saying let u equal x cubed plus 1. Then this would imply that y is 1 over u to the 5th. Therefore, now we have two functions. We have u equals x cubed plus 1, and we have y equals 1 over u to the power of 5. That is, u is a function of x, and y is a function of u. And according to the chain rule, we said that dy by dx is going to be dy by du multiplied by du by dx. Well, dy by du is 1 over u to the 5th, the derivative of this, which is the derivative of u to the minus 5, which is minus 5 u to the minus 6, which is minus 5 over u to the 6. And du by dx is the derivative with respect to x of x cubed plus 1, which is just 3x squared. Therefore, we can say that dy by dx is dy by du multiplied by du by dx, which is dy by du is this term, which is minus 5 u to the power 6 multiplied by du by dx, which is this term, which is 3x squared. However, we said that u is x cubed plus 1. So wherever we see u, we have to replace that by x cubed plus 1. So we have minus 5 x cubed plus 1 to the power of 6 multiplied by 3x squared. Therefore, we have minus 15x squared over x cubed plus 1 to the power of 6. Let us look at another example. Example number 3. Suppose I had a function s of t equals t cubed plus 1 all over t squared minus 5 and raised to the 4th power. If you haven't already done so, please click like, subscribe. This really helps me a lot. It brings me up to the top of YouTube rankings. This will help me grow my channel and help me bring valuable content to you, the audience. Thank you again. Now let's make another substitution. Let's let u equal t cubed plus 1 all over t squared minus 5. And we were asked to find ds dt. And using the chain rule, we can say that ds dt is ds by du multiplied by du by dt. Now s will be, we let u equal t cubed plus 1 all over t squared minus 5, so that will be u to the 4th. So we can find ds by du, that will be just 4u cubed by the power rule. And now du by dt, we need to take the derivative of this, right? Now this is a quotient, so we have to apply the quotient rule. Check out my previous video on how to do that using the quotient rule. So du by dt is going to be the bottom times the derivative of the top, which is just 3t squared, minus the top, which is t cubed plus 1, multiplied by the derivative of the bottom. The the root of the bottom, t squared minus 5 is just 2t, all over the bottom squared. Let us simplify this. We have a 3t squared multiplied by t squared minus 5. 3t squared times t squared, that's going to be 3t to the 4th. 3t squared multiplied by minus 5, that's going to be minus 15t squared. And then continuing, we need to multiply this by this. We have minus sign in front. So 2t multiplied by minus t cubed, that's going to be minus 2t to the 4th, minus 2t to the 4th. And then we have 2t multiplied by negative 1, that's going to be minus 2t, all over t squared minus 5 all squared. Let's continue. We can simplify the top. We have 3t to the 4th and minus 2t to the 4th. That's going to be t to the 4th. And then we have a minus 15t squared minus 2t all over t squared minus 5 all squared. This is du by dt. Okay? So remember we said that ds by dt is going to be ds by du multiplied by du by dt. And we have both those things. So ds by du is 4u cubed multiplied by du by dt is this whole thing here. So that's going to be multiplied by t4 minus 15t squared minus 2t over t squared minus 5 all squared. So there's a lot of algebra here. So this is going to give you great practice for doing good algebra. So continuing, we have ds by dt is going to be 4u cubed. However, we're going to replace the u by what we had substituted, right? We had t cubed plus 1 over t squared minus 5. That's u, all cubed, and multiplied by du by dt. That's this here, du by dt is all this. So that's t to the 4 minus 15t squared minus 2t all over t squared minus 5 all squared. Let us rewrite this as 4t cubed plus 1 all cubed over t squared minus 5 all cubed multiplied by, now the top we can pull out a t and we'll have t cubed minus 15t minus 2 all over t squared minus 5 all squared. Now working on the top, looking at this stuff here, I'm going to pull out the t in front, so we're going to have 4t cubed plus 1 cubed multiplied by t cubed minus 15t minus 2. And the bottom, we have a t squared minus 5 cubed and a t squared minus 5 squared. We're going to combine those terms and we're going to say t squared minus 5 raised to the 5th power. And this is our answer, ds by dt. Please try these examples a few times, try them out on your own and see if you get the same answer. I hope you enjoyed this video. Please click like, subscribe, and comment below, and see you next time.